Okay, another recap starter. If you can pause the video and have a go at the questions on the screen, please. Okay, hopefully you've had a go at them. And pause the video and have a go at these. This question in the top left is the same as what you'll have done on the last slide, but your solution to that will help you with the one below, so I've left it up there. So pause the video and have a go at these, please. Okay, hopefully you've had a good go at them. Let's have a go through them. So this first one, a conversion. We've not been told a conversion rate, but we've been given a graph that tells us the same thing. I'm going to try and find a nice easy conversion on this. So 100 Emirati dirhams, I'm going to call them ED from now on, is equal to £20. So 100, I'm going to change colour, I don't like that. So 100 ED is equal to £20. We want to know, well, what is 2,200 ED? And how is that going to equate to pounds? Well, to get from here to here, we've times by 22. So the amount of pounds we get as well should also times by 22, because we can see it's a linear graph, it goes up, it's directly proportional, it goes up in the same amount for both of them. So when we times this by 2, we're going to get 440 pounds for 2,200 Emirati dirhams. Tom wants to buy a camera. In London the camera costs £380 and in Abu Dhabi it costs 2,000 dirhams. In which country is the camera cheaper and by how much? So we want to convert one of these into the other currency. So I'm going to convert this one into pounds. So we know, again, write out our conversion rate, what we know, 1,000 ED equals to £20. I want to know what 2,000 ED is going to equal in pounds, because that's the cost of our camera there. So that's times by 20. So if I times by 20 here, the camera, so that £400 there is the price of the camera in Abu Dhabi. The price of the camera in London is £380. So it's cheaper in London by £20, because 400, the difference between 400 and 380 is 20. Okay, I'm going to skip to the next slide and I'm going to do all these journey, speed, distance, time questions together. So, doing these at the same time really is always advisable to set up if it's a speed, distance, time question or any compound measure, so a density question, where it's got more than one stage. I would draw yourself a little table. So this is stage 1, stage 2, stage 3, and an overall column. And then I'm going to have my speed, my distance, and my time. So separate all them out and make yourself a nice little two-way table where we can fill in values as we find them, and it makes it a lot easier to manage what you've actually found and what we can find. So, reading the question and let's fill in some values that we can. So, in stage 1, he drives at an average speed of 30 kilometers per hour. So, 30 is our speed, and for 45 minutes. Before we write that in there, we're talking about kilometers an hour, so we need our time to be in hours as well. 45 minutes, that's 3/4 of an hour, so 0.75 hours. So I'm going to put 0.75 in here. We've got to keep our units the same for our calculations and our formulas to work. So we know that speed equals to distance over time. So to find distance, we can do speed times time. So I'm going to do 30 times 0.75, and that is going to give me my answer in here of 22.5 kilometers. So that is our answer to the first question. That is how far he's travelled in stage 1 of his journey. Carrying on with this table for part 2, so in stage 2 of his journey, Lee drives an average speed of 50. So I'm going to do this in a different colour to make, it's a different part of the question. So Lee drives 50 kilometers per hour for 2 hours 48 minutes. So 2 hours 48 minutes. That's not an easy one to convert like it was for 3/4 of an hour. But to convert this to hours, you just want to do 480 divided by 60 because there's 60 minutes in an hour. You're going to get that as 4/5 or 0.8. So we know that 2 hours and 48 minutes is the same as 2.8 hours. So I'm going to write that in here. And overall, this is why I've done an overall column, because sometimes they tell us the total journey statistics. Overall, over the 3 stages, Lee travels 200 kilometers, so his distance would be 200 overall for 4 hours. Trying to fill in some things we can do now. So we can quite easily find this. So we can do 4 subtract 2.8 subtract 0.75. So I'm going to do that, and that gets me 0.45. So that's the time he travelled in stage 3 of his journey. We can find this part here as well quite easily. Well, again, we know speed equals distance over time, so distance equals to speed times by the time. That's a rearrangement of our formula. If you know it through the triangles, I'll draw that bigger so I can actually represent it. If you know this through the triangles, so speed, distance, time triangle, you know that you cover up the one that you want to find, so I'd cover up the distance, and that is speed times by time. So that's going to equal to 50 times by 2.8, and that's going to give me 140. So I fill in 140 there. We can then find the distance for part 3 quite easily. We can do 200, subtract 140, subtract 22.5, because these 3 distances must add up to make 200. So I've just subtracted these 2 from here. And that's going to get me 37.5. We've been asked to find the average speed of his journey, so actually we've been doing all this work to try and find this one here that I've just put a bit of a red in the corner of. We can do that now. We know speed equals distance over time, so the final part of my working will be, so this is for part 3, speed equals to distance over time, so 37.5 over 0.45. Get your calculator out, and we're going to get 83.3 recurring. So I'll write that large here, 83.3 recurring kilometers an hour. He went quite fast. Might have been on the motorway. Okay, final question. Simultaneous equations. We want to get some of the coefficients to be the same. I think we can get these ones to be the same. So I'm going to multiply this equation by 2 and this equation by 3. That is going to get us 6x for both. So I'll do them over here. So that will be 6x minus 8y equals to 36, times all these 3 terms by 2, like I said I would. And that's equation 1 again. So equation 1 and equation 2 on the bottom. Equation 2 times everything by 3. So 6x, and then that will be minus 15y because I've times it by 3, and 19 times by 3 is going to give me 57. You may want to write this out so you've got your larger value on top to avoid having some negatives. I'm going to not do that this time because I'm kind of confident in my work with negatives, but that's an option you could do. These are both positives here. So when they're both the same sign with the same number at the front, we want to subtract them from each other. So if I subtract these equations, 6x take away 6x is 0, minus 8y, subtract minus 15y. Remember, this here, two negatives, subtracting a negative will turn into a positive. So we're really doing minus 8 plus 15. So that gets me 7y, positive 7y. And then I'm going to do 36 subtract 57, which is minus 21. So y equals to minus 3. Just going to rub a little bit of this working out now. We then need to substitute y equals to minus 3 into any of the equations we've got. I'm going to substitute it into equation 1, just because I think that might be the easiest, who knows. So 3x minus 4 lots of minus 3 equals to 18. Negative 4 times by negative 3 is what we're doing there. That's going to leave me with positive 12. So 3x plus 12 equals to 18. So 3x equals to 30, adding 12 to both sides. So therefore x equals to 10. So if we were to write out a full answer, if we had an answer line in an exam, we would just write it out one more time in a pair. So x equals 10, y equals minus 3.